All right. Next up, we have a couple lightning talks. Jeff Houston is here to talk to us about Facebook versus the Great Firewall of China. Jeff, in the room? Here he comes. Run, run. Like lightning. Excellent.
Like I said, this will take about 3 minutes. So I heard on Monday, and so did you, these scary stories about just how good these folk are at spying and doing various nefarious things on the network, and how wonderful, you know, they'd managed to hack into Firefox and tap Tor and so on. But you've got to understand that this is government work. And, you know, normally a good day in government is just well-intentioned incompetence, and a bad day gets malicious incompetence, but it's still kind of just incompetence. So we're in China for an APNIC meeting in August, and as you're probably aware, normally within China, Facebook is not functional. They just don't like it. So the directive comes out from government, Facebook mustn't work. So how do they make it not work? So if you're outside China, tunneled out or anything else, and you basically do a dig for facebook.com, what you see on the left is what happens. You dig and you get 69s, 171, 229, 25, right? If you're inside China, you get 1.1.1.1. And, you know, like this afternoon when we heard about IP reputation, if there's an IP address that has an amazing reputation, it's 1.1.1.1. Fascinating. So let's just figure out who owns these two IP addresses. Well, if I do a who is on 69 whatever, I come up with Facebook. But when I do a who is on 1.1.1.1, I come up with me. I'm like, it's really nice to sort of be Facebook in China, but you know, this is a little bit weird. So, okay, let's forget about the outside and let's just focus on that one address inside China, 1.1.1.1. So I'm going to try and connect to Facebook, you know, tap it in the bar and I get back 1.1.1.1, right? So are they black holing that address? So let's just look at this. And let's just look at a trace route to 1.1.1.1. You can try it yourself right now if you want, and what you see is it will go to an address, both inside and outside. And right here in this room, and the address that it should go to is 65.210.126.78, right? Who's that? Google. This is getting weird. So the next question you should be asking is, why is 1.1.1.1 being routed right into Google? Well, there is an answer, because I wanted it so, and that's the letter of authority. So this is now getting even weirder, because I'm running a darknet traffic collector at 1.1.1.1 in California with Google. Thank you, Google. This is terrific. So here's some of the traffic that we see coming in to that darknet collector. It's all incoming sins from China. So, you know, inside all this area of who's actually spying on who and why, I still don't understand why whenever you want to go to Facebook in China, you get sent to Google and we're watching. That's pretty bizarre. But it gets stranger, because sometimes when you ask that question, and I asked m.rootservers.net, in China it doesn't just tell you the NS servers, no, it gives you the real answer. And really, in China, despite all their efforts, Facebook is everywhere. Thank you.
Thanks, Jeff. Next up, Scott White with Google talking about SNMP and what he wants to see next.
Oh, do I need slides?
Oh, cool.
All right, it's always hard to follow Jeff. And I don't know if Nathan Hickson's in the room, but he's the one who helped Jeff out with that, so good job, Nathan. Okay, so lightning talk, and we want to get done. So we can do better than SNMP. Facebook gave a very, very good talk today. I wanted to thank them for that. They unwittingly helped move forward my thesis here, though, which is basically we have two ways to get data out of our networks right now and onto our networks, which is SNMP and CLI scraping. In fact, they reminded me of one I completely forgot about, which is syslog. One of the reasons I forgot about syslog is it's in my opinion, it's actually even less parsable than most things. The syslog was kind of designed for human consumption, and you know, every implementation spits out different syslogs, so you have to take it to the next level to actually parse you know, information and make that programmatic in some way. So kudos to them for doing that as well. You know, S is a lie. It's not simple. It's impossible to use for large data set retrieval. We're performance bound. It's got these, you know, inverted column row semantics, the data structures that, you know, mean that you end up having to force the OS to do all kinds of crazy backflips to get it to be able to populate an answer before it gives it to you. And CLI scraping, I mean, do we even need to talk about this? So what do we need? We need to retrieve large data sets. Like I said, we need high resolution without hammering the CPU memory. We need to get the data off the box, as much data as we can, as quick as we can. What would we like? Well, we would like money, fame, power, et cetera. But what we would like in this context is a flexible framework. So I think what I would suggest here is a data-driven model, a data model-driven approach where I query a network node. It has implemented some data model. It sends it to me, and then I can inspect that. I can select, you know, via some kind of filtering capability, I can select things I like, and then I subscribe to them with some metadata that says how often, push, pull. You know, format agnostic. I mean, maybe I want JSON, maybe somebody else wants XML, maybe somebody else wants ASN1 because they want this to, you know, easily transition out of their existing SNMP. Maybe somebody wants ProcNet because, you know, their servers are already spitting out information in that format and they want to unify things. I think there's no reason why we couldn't make this extensible to all those needs. Transport options, I think, also should be negotiable. One quick example would be interface data. So, you know, a lot of people use interface data for billing. They're not really going to want to lose that data. Other people are going to use interface data for novel things like, you know, real-time traffic engineering, and the time value of the data is lost once the packets has to retransmit. So maybe I want to do UDP for this, and they want to do TCP. That we should allow that flexibility. Timestamps, you know, drives me crazy. So you know, I'm not talking about necessarily time series format where every single piece of data has a timestamp attached, but at least having a timestamp associated with tables, whatever, so that you can get the, you know when the data was collected, you know, authoritatively. Oh, and I don't know how to go back. PubSub. So I think underlying this is the assumption that we have some kind of PubSub infrastructure. There's many different ways it's been implemented. There's lots of different solutions for that. But the advantage there is we don't have to reinvent those things, and we can push a lot of the complexity, reliability, that sort of thing out of this protocol where it shouldn't live in the first place. Oh, I got ahead of myself there. So basically, yeah, the whole point of this is, you know, I want to get data off the box and then figure out what to do with it. I don't want this, you know, switch, this top of rack switch to have to do any kind of thinking at all, any kind of computation. I just want it to tell me what it can tell me, and then I subscribe to it, and then it just starts reporting. Along with that, though, I mean, we can get fancier, right? We can do asynchronous, we can do synchronous. You know, we can have the thing set up so that, you know, I can set some thresholds potentially, and it'll report to me if it has that capability when the threshold's broken, or just some event like in a link down or something. You know, or the more generic subscriptions where I get the data, you know, I say I want this data every 5 minutes, I want this data every 5 seconds, I want this data every 5 days, and it just sets it up. Streamings, one-offs, you know, maybe I want to get a rib dump. Maybe I want to actually have the rib stream. You know, maybe I want to use BMP, and I can set that up. And then push and pull. I should be able to do all this stuff with a single framework, I think, with today's technology. So I mentioned BMP. I don't see any reason why we need to reinvent protocols to do this as well. I mean, one thing we could do, I think that's cool with this, is we could, as part of the capability negotiation, discover, oh, you do S-flow. Oh, well, I would actually like you to set up these S-flow feeds for me. And so now I have a way to dynamically set up S-flow, which I don't have the capability of doing right now. Right now I have to do it via configuration, and it's very static. You know, I think it's a one-size-shoe-fits-all type thing. And just to reiterate the point, I don't think we have to invent much. I mean, you know, if we want to go with ITF, and this is what I'm interested in right now, I think, you know, netconf with some nice extensions would be very useful. We have the Yang model for data models already, kind of well understood. As I mentioned, we have plenty of pub/sub implementations. We already understand command and control. What we really want to do here is solve that last piece where, you know, I'm trying to run Puppet on everything, and you know, or whatever, Chef, and I want to solve this last piece where I can get the data on and off the routers just as easily as I can get them on and off my servers. And so in the end, I think the best place for this to live, hopefully, is the I2S working group. So I'm going to co-author a use case draft as the starting point to hopefully drive an information model and then actually get some implementations going. That's it. Thank you.
All right, and that's a wrap for today. Beer and Gear is kicking off in the Komatki rooms, and the social post-Beer and Gear is actually moving from the Mesquite Terrace to the Komatki patio. It saves you at least 20 seconds of walking outside the Beer and Gear. Please use it wisely. Thank you, everyone. And don't forget to fill out your surveys, please. Thanks.